Okay, this video is called the seesaw of hypertension. So the first issue with hypertension is, are you in a sympathetic or a parasympathetic phase? So sympathetic is the sympathetic autonomic nervous system, usually referred to as SANS. It's also your stress response. And the classic metaphor is being chased by a tiger in the dark. Okay, so when you're being chased by a tiger, all you care about is surviving for the next 30 minutes. It's a very physical, impulsive moment. Do you climb a tree? Do you hide? Do you try to fight somehow? And when you're walking down a path in a forest or a jungle, that's the basic question you ask yourself. Are things okay or they're not okay? Things are okay, not okay. So sympathetic SANS is things are not okay. You need to make an immediate physical response. Fight, flight, or freeze, to hide, so to speak, or to just not move. All right. PANS is parasympathetic autonomic nervous system. And that is, when things are good, things are cool. All right, so PANS, the mnemonic for that is to feed and breed, to eat, to make love, to rest and digest. Okay, it's also the thoughtful time of the human brain, a time to contemplate for rhyme, rhetoric, and logic, playful, joking, creative. That's when you want to do your creative work. All right, so you want to spend as much of your life as you can in PANS, in parasympathetic. And your blood pressure, of course, goes up a lot when you're in SANS, sympathetic. All right, now let's say you're in parasympathetic. There's two major parts of parasympathetic. There's the growth phase. So if you just ate a big meal and you're resting and you're sleepy, your body's full of calories, you've been sedentary all day, your cells want to go into a growth mode. They've got lots of nutritious resources, nutrients available to make copies of themselves, okay? To store fat, all of that kind of stuff. But it's also bad because it can cause cancer to grow. And what I'm trying to say here is you want to spend more of your time in this phase, sort of a maintenance phase, a restoration phase. So the two competing pathways are mTOR here, mammalian target or rapamycin, also called mechanism target or rapamycin. And this one is the AMPK pathway. AMPK pathway is sort of a restoration pathway. So you might have previously been running a race or working out intensely, a bit of a sympathetic activity, and then when you're resting, your body has to replenish its ATP levels inside the cells. Autophagy, it'll sort of go over its mitochondria, mitophagy, to make sure your mitochondria are functioning well and get rid of the bad ones, okay? Mitochondrial biogenesis, to rebuild new mitochondria so you'll have more exercise stamina for your next workout. And this is a good phase because it essentially tells the cell, look, we're kind of tired. We need to restore our ATP. This is not a time for growth. So this is not a time that cancer is going to replicate. And things that help you to stay in a parasympathetic phase and to lower your stress is having a sense of purpose. All the major religions, the people are healthier than the non-religious people. An attitude of gratitude. Your melatonin's high, you can sleep, the love, the oxytocin, trust, and friendship hormone. All of that stuff is good, And earlier when I talked about walking down a path in a forest, that's what the purpose of the brain is, to walk down a path in the forest, a jungle, or a prairie, and to survive. And part of survival is to always be alert to what's going on. Things are cool or not cool, safe, not safe, okay? So we like to be in a safe place to the extent we can so we can focus on whatever we care about, what we love, whatever we're interested in. Whatever we're trying to accomplish at that moment. Okay, now here is the hypertension seesaw. So these are all the things for hypertension right here on the seesaw that cause hypertension. And these are all the things that prevent hypertension. So basically we know excessive dietary fat sticks the red blood cells together into a rouleau formation, blood sludge. There's a great McDougall video on his YouTube channel. High-fat meal blood sludge. It's only about 50 seconds long from the work done by Roy Swank to show the high-fat diet sludges the red blood cells together, okay? And that means you're pumping a milkshake up to your brain, and that's the reason you have a blood pressure to pump blood to the top of your brain, cerebral cortex. You have to pump against gravity. Normal blood's like water, easy to pump. Thick blood with the fat sludge and RBCs together is like a milkshake, so you need higher pressure. Sodium, Na plus for natrium, the Latin word for sodium, causes vasoconstriction, narrows the arteries, so now you're pumping a milkshake through a narrowed system. Pressure has to go up. So these are the two main dominant things causing hypertension. But stress also causes hypertension because it's a vasoconstrictor. Sleep deprivation and caffeine raise the same hormones. Catecholamines, meaning adrenaline and noradrenaline, and cortisol. Okay, they also crank up the lipids in the blood and the sugar in the blood, glucose in the blood, to give you energy to run from a tiger, so to speak. But that also means it increases your risk of diabetes. So these are things that all start working together in hypertension. You're going to reabsorb sodium from the kidney because you want to increase your blood volume, because you're going to have pump more blood to all your muscles that are running actively. And simultaneously, unfortunately, you're going to be peeing out your potassium. So stress will make you lose potassium from your body. Not good. Okay, you lose magnesium from your body. Especially losing the magnesium is relevant in this context. Okay, alcohol raises blood pressure. Tobacco raises blood pressure. Being sedentary raises your blood pressure, causes insulin resistance. Being iron overloaded leads to amyloid clotting in the blood, can raise blood viscosity. Leaky gut causes increased bacterial endotoxins in the blood, like LPS from gram-negative bacteria, LTA from gram-positive bacteria. That can cause amyloid clotting, can raise your blood pressure. Same thing with iron overload, I spoke about a minute ago. Obesity causes insulin resistance, can raise your blood pressure. Diabetes. So these are all things worsening hypertension. Here's what makes things better. Basically everything that comes from plant. Potassium, P for plant, P for potassium. Magnesium, it's in the center of chlorophyll. It's what holds on to the second and third phosphate on the ATP. You need that for your ATP reactions, like the sodium-potassium ATP pump on the plasma cell membrane. Religion, people in the major religions are healthier, lowers their stress. Having a strong sense of purpose. You know, my purpose in life is to learn and teach medical and nutritional stuff. That makes me happy, gives me something to do, so I'm busy, okay? I'm not distracted. All right, dietary fiber prevents leaky gut, so that protects your blood pressure. Sun causes a release of nitric oxide precursors, which lowers your blood pressure, makes you feel good when you walk out in the sun. The greens contain your plant nitrates, and the antioxidants are in plants, and those run the oral nitric oxide conversion cycle. The plant nitrates, NO3 on the back of your tongue, the bacteria convert them to NO2, nitrites go to your stomach acid makes them nitric oxide, NO goes into your blood, systemic vasodilation from the nitric oxide. So that is the hypertension seesaw. I'll just give you a little more information about it. You got what's called a K factor, a ratio of potassium, K for collium, Latin word for potassium, to sodium. And normally you want it at least 5-to-1 to prevent hypertension. Our ancestors probably had it more in the ballpark of 16 to 20 to 1. Okay? And there's a lot of reasons for this, because you need this at least 5-to-1. I really think it should be at least 10-to-1 to prevent hypertension, because it gets the sodium-potassium ATP pumps to work well in the plasma membrane. I'll show you what that's all about. And it's pretty easy to do. A lot of plant foods are more than 100-to-1 more potassium than sodium. Okay, normally in a cell, you'll have higher sodium outside the cell, same as in the blood, 140. Inside the cell, call it 14. All right, so 10 times more outside the cell. Because the sodium-potassium pump is only pumping in 2 positive charges and 3 negative charges out, there's a net charge flow. It's the sodium ion out, so that's a current moving out. Charge is stored across a membrane. This is the electrical generator, so it's like a battery. That's how the plasma membrane of a cell works. You can call it the sodium battery. That's how Richard Moore, MD, PhD, who wrote the book High Blood Pressure Solution, best book ever written on hypertension, that's how he described it, the sodium battery. And only the sodium-potassium pump pumps sodium out. Everything else lets sodium come in. And sodium is like the angry poor. If you wanted to give a name to the ion, sodium would be like the angry poor trying to bust into the city, pissed off that he's outside the city. Okay? Potassium is sort of like the middle class trying to make things work. And magnesium is the mellow out middle class. It mellows things out. There's another reason why it mellows things out. I'm not going to go into it right at the moment, blocking the NMDA receptor in the brain. But think of M for mellow things out. Also M for middle class. It's the other middle class ion with the potassium. Okay? Now calcium is the aristocrat. And it is bossy. It walks in the room. It doesn't care what anyone else wants. It says, do it my way. And I joke that it's like my ex-wife. Okay? And so potassium, when it enters the vascular smooth muscle cell, it says contract now. And that means the cell will contract. And when the cell contracts, it tightens around the artery. So imagine this is the artery. It's circumferential, and it clamps down on the artery, lowers the diameter of that artery. So when that artery diameter is decreased, you're pumping blood through a tight tube, pipe, so to speak. Pressure has to go up. All right, so in order to lower to open up that artery, you got to pump this calcium out of the cell. When you're pumping it, the extracellular space has a gradient. It's about 10,000 to 15,000 times higher in calcium concentration, so you need a pump. and you couple it to the electrochemical gradient with sodium. You let in 3 sodium and then you can pump out 1 calcium. And this is called the NACA exchanger. Na for natrium, sodium, Ca for calcium, and X for exchanger. So it's usually abbreviated NCX. And that's how the plasma membrane does work. Okay? It's also used for pumping protons and for pumping amino acids. It is the battery, the energy power of the plasma cell membrane. So that's interesting how a gradient of charge is used as an electrical power system in a cell. Whenever calcium is high in a cell, the cell does what it does. So in a neuron, it'll release its neurotransmitter. In a smooth muscle cell, it will contract. Okay, and you have to have a fixed amount of potassium and sodium inside the cell. If one goes up, as sodium enters, then potassium has to exit. It's always going to be a fixed amount because you have to maintain osmolality. Over 98% of the cations in a cell, that means positively charged ions, are potassium and sodium. So that amount of potassium and sodium together has to be fixed ratio. So what that means is if you're eating a lot more dietary sodium, you're gradually going to accumulate sodium intracellular and lose potassium, and you're going to urinate and void out your extra potassium, and that's going to dissipate this gradient across your plasma membrane, sodium-potassium ATP pump. And so then you're going to weaken your pumping power ability of your sodium battery, so to speak, to pump out calcium. And that's a problem because then your vascular smooth muscle cells are going to stay more tonically, consistently, continuously contracted around your small arterioles, and that's going to raise your blood pressure. Okay, so that's what the sodium potassium pump is all about with regard to hypertension. And on my last slide, I think I'm just showing you that ratio as a reminder. You can't win this game any way other than to eat more potassium and eat less sodium and give your body what it's used to. Modern Americans have a K factor of about 0.4, meaning we're eating 2.5 times more sodium than potassium. And that's why most people are hypertensive, most middle-aged and older adults. And the way to reverse that is minimize your dietary fat, like we talked about on the seesaw, so you don't get blood sludge. Increase your dietary potassium by eating more plants. Decrease your dietary sodium. And if you do that, your blood pressure will improve. And then all the other good stuff's in plants too. You need the magnesium. That's an important thing too. But you get it. Magnesium's right in the center of chlorophyll. So just by eating a plant, they're loaded with potassium. Magnesium's in the center of chlorophyll. They've also got the plant nitrates and the plant antioxidants and the plant fiber. All of that stuff improves your blood pressure. So that is the hypertension seesaw. I hope that was helpful.